Good morning, all. Today's session, we are going to discuss the physiology of language and speech, which is very important mean of communication, especially in cases of humans. What will be the objective at the end of this session? Will be able to understand the various speech areas located in the brain. What is the pathway involved for speech, and what are the various theories of speech production? Then we classify the speech and language disorder and will come to know and understand physiological basis of this speech and language disorders. So let us study speech or language. It is an example of skilled voluntary movement. Definition. By definition, it is a process to understand spoken and printed words and to express ideas in speech and in writing. Normally, speech is produced on expression by movement of the vocal cords. Human beings are also capable of expressing their efficiencies and emotions without using speech or language with the help of work language, that is conveying message through quality of work that the person is doing. Body language conveying message through the physical changes, and expressive language conveying the message through the emotional feelings, just by the emotional expressions. However, generally it is stated that language is the means of communicating one's thought through spoken words or in writing, and is also the medium for all delicate interpersonal transactions. What are the various types of speech? As such, there are two: spoken speech and written speech. Spoken speech, it means understanding the spoken words and expressing one's ideas in speech. For the spoken speech, the mechanism involved will be one should have ability for the spoken speech to hear the sound, and to hear the sound, intact auditory pathway from ears to the primary auditory area number 41 has to be there. Then understand the heard sound. Hearing sound, then understanding the sound which are being heard, and for this intact adjacent auditory psychic areas like area 20 and 21 are required. And then after hearing and understanding the heard sound, express ideas in the speech. Intact auditory pathway, auditory speech center called Wernicke's area has to be there. Then the second form of speech is written speech, understanding written words and expressing the ideas in writing. What is the mechanism involved? The person should be able to first see the words, and for this intact visual pathway from eyes to primary visual cortex has to be there. Then the person should correctly interpret the written words, and for this intact secondary visual areas like area 18 and 90 are mandatory, and then express ideas in writing. Intact visual speech center called Digerine's area number 39 has to be there. Language and speech areas in the brain are mainly divided into two types. That is, there are two receptive areas and two executive areas. And therefore, there are four total areas which are involved in the production of language as well as speech and located in the brain. These four main areas are collectively known as language zone, as located around the sylvian fissure, also called perisylvian areas. Let us see one by one. Receptive areas, Wernicke's area and the angular gyrus. As we can see here, this is the Wernicke's area and this is the angular gyrus area. Then executive area, Broca's area and the Exner area. This is the Broca's area and this is Exner area, which are located. All these areas are located in the association cortex, that is adjacent to the cortical areas that are essential in the language formation. Receptive areas, which are also called sensory speech areas. They are so called as they receive and process sensory information for speech. These are Wernicke's area, as we can see here. Area number 22 in this particular diagram. And angular gyrus, that is area 39, this particular area. Area 41 and 42, along with 39, 41 and 42. That this particular zone is associated with the receptive areas responsible for the language or the speech. Wernicke's area, we are talking about this particular area. It is described by Sir R. Wernicke in the year 1874 for the first time. It is located in the superior temporal gyrus, as we can see here. Function, it processes sensory information from somatic, sensory, visual, and auditory cortices, which is essential for comprehension, recognition, and construction of words and language. Thus, it is concerned with comprehension. That means it is concerned with interpretation and understanding of auditory as well as visual information, and hence this particular Wernicke's area is said to subserve the perception of spoken language. And therefore, whenever there will be lesion in the Wernicke's area, person will be able to speak, but words they frame and put together will have no meaning. Angular gyrus, that is Digerine's area or the area 39. Digerine's area, we are talking about this particular area. This is in the angular gyrus. Angular gyrus is location. It is the angular gyrus is located in the inferior parietal lobe. This particular part, anterior to visual receptive area. Function, it is concerned with comprehension, that is interpretation and understanding of visual information. Hence, it is referred to subserve the perception of written language. Area 41 and 42, this particular area, are also included in receptive areas that take part in processing spoken language. After the sensory area, there is a expressive areas, which is also called executive areas. They are so called. They are also called motor speech areas, as they execute expression of speech. And they are Broca's areas, that is area 44 and 45. This particular, and Exner writing area. This particular. Broca's area, it was described for the first time by Sir Paul Broca in the year 1865. It is located in the inferior frontal gyrus, as we can see here, inferior frontal gyrus. It regulates function of muscles of lips, tongue, pharynx, and larynx. What is the overall function of Broca's area? Let us see. It receives information from the Wernicke's area. This is the Wernicke's area. It is receiving information from the Wernicke's area, where the information is processed into detailed and coordinated pattern, and then ultimately from Broca's area, the information gets projected to the motor cortex, which initiate appropriate movement of lips, tongues, and larynx, and thereby produce the spoken speech, that is the vocalization. And therefore, whenever there is a lesion in the Broca's area, person is able of comprehending a spoken or written word, but is not able to say the Exner area. This particular location, it is located in the middle frontal gyrus, anterior to premotor area. Middle frontal gyrus. Function, it receives information from the Broca's area, from Broca's area to the Exner area, where the information is processed into a detailed and coordinated pattern, which is then projected to the motor cortex, which initiate the appropriate movements of the hands and fingers and to produce the written speech. That means this particular area is involved in the production and formation of the written speech, whereas the Broca's area is basically concerned with the spoken speech. Thus, there are two parallel systems for speech. One is for understanding the spoken words and producing the speech, whereas the other for understanding the written word and producing writing. What is the Arcuate fasciculus? It is a rich network of nerve fibers. It connects the Wernicke's area with the Broca's area. This is the Broca's area, this is the Wernicke's area, and the two areas are connected by the group of nerve fibers, which are collectively called as Arcuate fasciculus. Thus, sensory and motor areas are intricately connected with each other. Area of speech product. Angular gyrus, it receives and preliminary process visual and auditory information or the inputs. Then this information from the angular gyrus is projected to Wernicke's area, as we can see here, from angular gyrus to the Wernicke's area, which comprehends these inputs through the arcuate fasciculus to and projecting it to the Broca's area. See, from Wernicke's area through the arcuate fasciculus, the information is going to the Broca's area, which further processes information into elaborate process of vocalization, and ultimately the information is projected to the motor cortex. Motor cortex uh, uh, initiate the activities of the speech apparatus, and this activity is mainly responsible for producing the, see here, all the information, the informatory inputs, sensory as well as vision inputs are collected to the angular gyrus. The information is going to the Wernicke's area, then via the arcuate fasciculus to the Broca's area. Broca's area is projecting into the motor cortex, which is initiating the activity in the speech apparatus, and thereby leads to production of this. In detail, the theory of speech production, which is involving both spoken as well as written speech, we can describe. Angular gyrus, as I said, it receives and preliminary processes visual and auditory information or the inputs. This information is projected to Wernicke's area. This Wernicke's area causes comprehension of this information received from the angular gyrus through the arcuate fasciculus. The information which is comprehended by the Wernicke's area in the detailed fashion is projected to the Broca's area. From Broca's area, information is sent to Exner's area. From Exner's area, ultimately information is getting projected to primary motor area 4 or the motor cortex, which then initiate the activities of the speech apparatus and initiate appropriate movements of muscles of the hands and fingers so as to produce the written speech, and as well as muscles of the lips, tongue, and the larynx in order to produce the spoken. Language function is closely associated with concept of cerebral dominance. This we have discussed while we had a discussion on the various cortical areas. It is highly lateralized function of brain residing in the left hemisphere in right-handed person, and this dominance is observed also in left-handed individuals. Expression of spoken speech. Person hears the sound with intact primary auditory area. This heard information is going to Wernicke's area. Wernicke's area causes interpretation and understanding of whatever words are heard, and this interpretation is brought about in a complete way and detailed way. And after that, the Wernicke's area is sending information via the arcuate fasciculus to the Broca's area, where detailed and coordinated pattern for vocalization. As we have seen here, the information from primary auditory area going to Wernicke's area, then through the arcuate fasciculus to the Broca's area. Information from the Broca's area is going to the primary motor area or the primary motor cortex, which causes movement of the appropriate muscles of the lips, tongue, and larynx, and produces words in order to reply. And this is nothing but the spoken expression for both spoken as well as written speech. Printed words are seen, then it is properly interpreted and understood by the visual association areas. Words are then converted into internal speech by the angular gyrus or the deferens area, that is area 39, and the information is ultimately projected into the Wernicke's area, where the interpretation and understanding of the internal speech is brought about. This internal speech information is sent to Broca's area, which causes detailed and coordinated pattern information is sent to Exner area for written speech. Exner's area along with the primary motor area 4 initiate appropriate muscle movements of the hands and fingers to produce the written speech, and from Broca's area, detailed, coordinated, and pattern information also goes to primary motor area, which initiate movement of the appropriate muscles of the lip, tongue, and larynx for the. From the Exner's area, information is going to primary motor cortex, which initiate the movements of hands and fingers for the written speech, and from the Broca's area, information is directly going to the primary motor area, that is 4, which initiate the muscles of movement of the muscles of lips, tongue, and larynx for the. Printed words are seen, properly interpreted and understood by the visual association area 18. Words are converted into internal speech by the angular gyrus and the deferens area, and information going to the Wernicke, which then cause interpretation and understanding of the internal. This information is ultimately projected from Wernicke's area to the Broca's area. Then from the Broca's area, detailed coordinated and pattern information is sent to Exner area. Exner area along with the primary motor area 4 initiate appropriate muscle movements of hands and fingers to produce the written speech. Then from Broca's area, detailed coordinated and pattern information also is going to the primary motor cortex to initiate movement of appropriate muscles of lips, tongue and larynx to produce the exactly what we have described in the previous slides. This is just the summary of that in the flow chart format, so as to be understood easily. After being familiar with various areas which are involved in the production of language, speech, written speech and spoken speech, and after being discussed with the detailed mechanism of speech production, now it's a time to discuss various disorders which are associated with speech and the language. These disorders are divided mainly in 4 categories. The first among which is the aphasia or dysphasia. It is loss or impairment of production and or comprehension of spoken or the written language because of the acquired lesions of the brain. Second, disturbances of the speech secondary to global diseases like dementia, in which speech and language functions are impaired as part of general. For example, in Alzheimer's, what we have discussed in the last session, disease, gradual loss of all aspects of language function occurs without any specific aphasia. Third part is dysarthria, defect in articulation of the speech with intact mental function and comprehension of spoken and written speech, cause disorder of muscles of articulation, may be due to flaccid or spastic kind of paralysis. And the fourth one is the aphonia, loss of voice because of the disorder of larynx or its innervation, that is nerve circulation. Coming on to the types of aphasia, which is the very first part in the classification of language disorder. Aphasias are broadly divided into 4 categories: motor, sensory, global, and dissociative language syndrome. Motor aphasia is also called Broca's aphasia or non-fluent aphasia or the expressive aphasia. It occurs in the lesion of Broca's area. Primary deficit is in the speech production with relative preservation of the comprehension. Mildest form, motor speech deficit with preservation of the comprehension and ability to write. Advanced form, there is complete loss of power of speaking. There is no paralysis of the speech apparatus, as patient can chew, swallow, clear the throat, cry or even vocalize without. Usually, lower part of the face and arm of the right side are weak. Then coming on to second type of aphasia, sensory aphasia, and as the name is suggesting, the sensory speech center is involved, that is the Wernicke's area, which is also called fluent or the receptive aphasia. Occurs in the lesion of Wernicke's area and is characterized by inability to differentiate word elements or phonemes, both spoken and written. Relatively fluent but paraphasic speech, that is use of malformed and inappropriate words. Inability to repeat written or the spoken words. The motor apparatus required for expression of language remains intact. Written letters are often combined into meaningless words. Next type is global aphasia. Lesion involve both Broca's as well as Wernicke's area. Lesion usually occur due to occlusion of the left internal carotid artery or middle cerebral artery. All aspects of speech and language are affected, and hence the name global aphasia. Able to say few simple words but characteristically fail to carry out a series of simple commands or naming of the objects. They cannot read, write or repeat what is said to them. Then the dissociative language syndrome. Language deficit resulting not due to lesion of cortical language areas but because of the disruption of the pathways which are joining them. For example, conduction aphasia, pure word deafness, pure word blindness, pure word mutism, anomic aphasia, and transcortical aphasia. Let us see one by one. Conduction aphasia causes separation of the auditory and motor language areas without damaging these areas. And their clinical feature, expression and comprehension remain intact, but inability to repeat simple phrases will be there. Fluency and paraphasia is self-initiated speech as seen in Wernicke's aphasia. Writing is invariably impaired. Pure word deafness or the auditory verbal agnosia, cause usually lesion is bilateral and is in the superior temporal gyrus. Clinical feature, impairment of auditory comprehension and repetition, and inability to write following dictation. Spontaneous writing and ability to comprehend written language are preserved, though they may not hear. Audiometry discloses no hearing defect. Pure word blindness, visual verbal agnosia. Lesion usually affect left visual cortex, geniculocalcrine tract, and connection of the visual cortex with the language areas. Clinical features will be inability to read aloud, to understand written script, and to name colors. Visual verbal color NOP. Understanding spoken language, repetition of what is heard, writing spontaneously to dictation and conversation, all are intact. Capacity to write fluently is retained, but he cannot read what has been written. Alexia without agraphia. Pure word mutism. Cause vascular lesion or localized injury to the frontal lobe. Clinical feature, loss of capacity to speak, and therefore pure word mutism. But perfect ability to write, to understand spoken words, to read silently with comprehension, and to repeat spoken words. So called pure word mutism or aphasia or pure motor aphasia of the DJ, right? Next type is anomic aphasia, cause lesion of angular gyrus in the categorical hemisphere without affecting language area. There is no difficulty with speech or understanding auditory information, but there is difficulty in understanding written language or the transcortical aphasia, which is supposed to be the last part. Isolation of language areas due to hypoxic injury, as occurs in carbon monoxide poisoning or prolonged hypotension, results in this particular syndrome. Either motor or the sensory speech area is isolated from rest of the cortex in same hemisphere. Accordingly, it results in transcortical motor aphasia, that is inability to initiate conversational speech with preservation of comprehension and repetition, or transcortical sensory aphasia, that is deficient auditory and visual word, but speech remains fluent and repetition is remarkably observed. Other language disorder, agraphias, loss of previously possessed ability to communicate through writing is called agraphia. Types of agraphia, aphasic agraphia, constructional agraphia, apraxic agraphia, and linguistic agraphia. Disorders of articulation. Impairment of articulation is called dysarthria. Articulation consists of contraction of pharynx, palate, tongue, and lips that alter the vocal sounds. In pure dysarthria, there is no abnormality of cortical language mechanism. They understand perfectly whatever is heard, have no difficulty in reading and writing, commonly due to neuromuscular disorders of phonation. Aphonia is impairment of phonation. It occurs because of the paralysis of the vocal cords. Also occurs due to paralysis of respiratory movements, as insufficient air is provided for the phonation or the vocal. With this, we comes to an end of the physiology of speech and language and the various disorders associated. Thank you.